as x approaches infinity. You already told me that the degree is 2. I will pull out the degree. And you can say, what are you talking about? How can you do that? And you should say, you cannot do that. X squared is not a common factor to all 3 terms. You can't do that. X squared is not a common factor. You can do that. Yes, I can. Here's why. As long as these 3 terms, because I have 3 terms, and these 2 terms, when I distribute x squared to them, I get that, then I'm safe. If I distribute x squared to these 2 terms and I get 3x squared plus 5, I'm okay. What is the purpose? To simplify it. So, x squared times what is x squared? Well, I know you're going to say 1.
1.
Good. Plus. Careful now, it has to be a fraction. X squared times what equals 2x?
2/1.
So in order for us to get to 2x, right, I have to have 2 over x. Let's do it again. X squared times 2 over x. I simplify an x, and I recover 2x. And plus x squared times what will be 3? Of course, it has to be a fraction. X squared simplifies with x squared, and I get 3. Can anyone try the denominator?
Would it be 3 plus 5 over x squared?
Brilliant, of course. Who was that? X squared times 3 is 3x squared. And x squared simplifies with x squared, and I get the 5. This was the whole purpose. To eliminate this. Okay, it's gone. Now let's analyze this. As x approaches infinity, you already told me that 1 over x approaches 0, or 1 over x limit is 0. What do you think about 2 over x? Where will that go? Where do you think 3 over x squared will go? Or 5 over x squared will go if x is infinity, approaching infinity? It's like saying I have $2 and I want to give everyone on the planet a piece of it. No one would get anything. I have $3 and I want to share it with millions of people. No one will get anything. It's 0. Same thing, I have $5 and I want to divide by infinity squared. No one will get anything. So where is this piece going? Where is this piece going? And where is this piece going? Only careful, only when x approaches infinity or negative infinity. That's what we are discussing. Where will these 3 pieces go?
It'll be closer to 0?
Absolutely. So then if they are 0, see, that's why I'm using my props. What is the limit?
0.
But what happened to 1 and what happened to 3?
It will be 1 over 3.
1 over 3. I covered everything that is gone. Everything is gone, but not 1 and not 3. So then,
I have a question.
Yes?
So in the beginning, you already said that as x approaches infinity, you would just take the coefficient of the numerator and the denominator. So will we have to simplify and go through all of this?
I just said that you can use it, but I would like to show you why, because we are in calculus. I said you can use that concept, that's fine, but I wanted to show you why, because in college algebra, I normally don't show why. I just say that's it. And I don't even talk about the limit.
Because on the test, I'm saying like on the test.
On the test, if the problem is asking you to show all steps, then you will have to show all steps. But That is acceptable. Good. I know we have a little to 3 minutes left. Let's see what we can do in 3 minutes so we don't waste the time. Would you like to choose anything else?
Can we do another one of those problems?
Say it again.
Can we do another one of those infinity problems?
Sure. Yes. Okay, so what about 37? Good point. Excellent. So I am on page 7. Good, awesome. So let's say 37 on 124, and we have limit Sx approaches infinity, 8x plus 1 divided by x squared. So one that I think we can finish in 2 minutes. So notice that in this situation, the numerator has degree what, and the denominator degree what?
In the numerator, the degree is 1.
Excellent.
The denominator is
Right. So the concept here, we have to be careful. Limit as x approaches infinity. I have to factor out the degree in the numerator. And the denominator, I don't have to do anything. This is it. A simple situation. Can anyone tell us, we have 2 terms and we have to have 2 terms in parentheses. What do you think is left in parentheses? So that this works. This times this is that. This times this is this. Otherwise, I can't. Yes, I'm ready.
8 plus 1 over x.
Awesome. Of course, thank you so much. Who was that?
So
Thank you. I will simplify an x. Now, please tell me, only in the situation of x approaches infinity, where is this going?
close to
0.
0.
Awesome. So I'm going to cover it up. It's gone. Here's what we have. Don't jump into conclusions because the degrees are not the same. So I have an 8 left in the numerator and an x left in the denominator. This is gone. I simplified one of them. Where is 8 over x going?
It's going to be 8 over 1.
X approaches infinity. This will approach infinity. So where is 8 over x going? Exactly where 1 over x is going. Who cares about 8? X approaches infinity. If it's 2 over x or 8 over x or 100 over x, the answer has to be the same because this approaches infinity.
Zero.
That's it. So that's why I was a little bit hesitant to say, yeah, use that, but there are different situations. So this is a specific case in which both degrees are the same. But you cannot use the same concept here because the degrees are not the same. So careful with that.